All right, we're in lesson 26, unit 5.4 of the pre-calculus book. This is actually on page 299 of the pre-cal book, page 299. I decided to teach this lesson from my geometry book that I wrote. So it's unit 8.5 of the geometry book I wrote because it's exactly what we need. So lesson 26, unit 5.4 of pre-calculus, page 299. And the name of the lesson in the pre-calculus book is applying trigonometric functions, which is what we're going to be doing here, okay? Now, the first thing that we needed to know is what sine, cosine, and tangent are, and we've already memorized those, right? So we know that tangent is the length of the leg opposite a particular angle over the length of the leg adjacent. If we're talking about angle A, the leg opposite angle A is the 3. It's across from it. The leg adjacent to angle A is the 4. So we could say that tangent angle A is equal to 3 divide 4. What we're doing really is trying to ingrain in your mind this, that the way a trigonometric ratio is set up is some function of an angle is equal to one side over another. A trigonometric ratio has 4 plug-in spots, basically, okay? The reason people have trouble solving trigonometric equations is because they don't know how to set up the ratio, and that's what we're going to learn about today. The sine of angle A is equal to the length of the leg opposite angle A, which was 3, over the hypotenuse 5. Now, we need to know which one is which. We've got to do the memory work, but after people do the memory work, they still can't solve sometimes because they fail to recognize there's 4 things. There's the function, there's the angle, and there's 2 sides to plug in. Now, the angle is one of the acute angles of the right triangle. We don't use the 90 as a plug-in to sine, cosine, and tangent, at least not as we begin to try to solve triangles. We're going to learn in the unit circle what the sine, cosine, and tangent of 90 is, but not as it applies to a right triangle out here in the world, okay? All right. And then we know that the cosine was the length of the leg adjacent to the A, which was the 4 over the hypotenuse 5. So cosine was 4/5. And again, we're seeing that we have some function of an acute angle is equal to one side over another. And so we're trying to get it in your mind that every time we write a trigonometric ratio, then what we're going to have is some function. I'll get that back. We're going to have some function of some acute angle is equal to one side over another. Now, what we need to know is which one do we fill in first and how do we figure it out? Well, we fill in the acute angle first. We're going to find the function second, and then we're going to set up the sides third. To figure out the function, we will see how the sides given are related to the angle that we chose. It's going to tell us which function. And to set up the fraction, we set it up like the function tells us to set it up. We're going to put that into action here in just a moment. Okay? So I'll let everybody get those notes taken, and then we'll look at some examples. I'm going to scroll past some pages in my geometry book that we're not going to use and go to some that we are going to use. We're going to use some geometry examples to solve, and then we're going to go back to the worksheet and do those. I want to show you 2 or 3 examples to start with. So we're just going to do enough out of the geometry book here to get the understanding down, and then we'll go to the trig book. There's another part of a definition, another definition we need in a minute. Everybody see those? Got that? All right. Everybody good? This is important down here, but you'll see it in just a second. We're going to fill in the acute angle first, function second, sides third. So here we go with that. I'll just show you what that says. We're going to find an acute angle. So we're going to establish what angle we have. We're going to look at the sides given and see how they're related to the angle that we chose. So we'll look at the sides and go, oh, I've got leg opposite, leg adjacent. So that must be tangent, you see. So looking at how the sides are related to the angle tells us what function to use, and then we do what the function says to set up the sides. And I'm going to move on past that because you're going to have that memorized in your head faster than you can write it down. So let's look at this example right here, and I'm going to white out all the extra stuff below it just to kind of show you what we're going to be doing, okay? Just kind of clean up a little bit here. All right. So this would be like what we would be doing. You would be given a right triangle. It's not a 30, 60, 90. So you can't use 30, 60, 90 rules. It's not 45, 45, 90. So if we're going to solve for x, we have to use sine, cosine, or tangent. So what's the first thing that you do to set up your trigonometric ratio? You find the acute angle, and the acute angle was 40. So the first thing we're going to do is fill in the angle slot. And so we're going to put that in 40 degrees. And then what do? You see how the sides given are related to the angle that you chose. See how the sides given are related to the angle that you chose. Now the first thing you need to do is determine whether those sides are a leg or a hypotenuse, right? Both of those are legs, because the hypotenuse is the one across from the right angle. Now, in relationship to the 40, the 6 is the leg adjacent because it's one of the rays that makes the 40-degree angle, right? And so it is the leg adjacent, and then x is the leg opposite. So the first thing we do is choose our acute angle. The second thing we do is see how the sides given are related to the angle that we chose, and we've seen that they're related in such a way that we have leg opposite and leg adjacent. And then we say, which function says that? Which function says leg opposite, leg adjacent? Tangent. And so that tells us to use the tangent function. So we found our angle first, and we found our function second. I see how we got that. And so then we're going to do what the function says to set up our fraction. And so the function says, tangent says you put which one on top? Leg opposite on top, x, over leg adjacent on bottom, 6. So we found the angle first. We saw how the sides were related to the angle. That told us which function. We did what the function said, and that helped us set up our fraction. At this point, we solve using the order of operations. Any questions on that? And then we'll solve. So now that we have our ratio, then we're going to solve. Now, we could do tangent 40 and round it to 4 decimal places. In a lot of geometry books or trigonometry books, there's going to be a trig table that rounds things to the nearest 10,000th. But if we want to avoid rounding, we wouldn't do that tangent 40 first. We would get x isolated and then punch it all in at one time, which is what we prefer to do so we don't have to round. So if I'm going to solve for x here, I would want to undo division by multiplication. So I would multiply both sides by 6. And what I would have is x equal 6 tangent 40. Now, to get the answer, I need to make sure that my calculator is in degree mode. And then I'm just going to punch it in, and it's going to give me the answer, okay? So we'll go to the calculator. Everybody see that? Everybody got that? Because it's going to disappear when I go to the calculator. All right? Okay, so we're going to do mode. Make sure we're in degrees. If you're not, you air down and over. So we're going to do 6 tangent 40. close, enter, 5.0. And you can round it to the nearest tenth, hundredth, whatever it specifies on the test. On the test there it says solve each and round to the nearest tenth. So if we were going to do that, that'd be 5. Okay, let's see how we got that. All right, let's do one more that is a word problem situation because we need to talk about something else that was in our trig book. So let me scroll to a word problem here, and let's just look at, whoops, let me find it right here. All right, look in your pre-calculus book on page 300. On page 300 at the bottom, it talks about angle of depression and angle of elevation. If I had a point on the ground and I was going up from that point, that angle right there would be called the angle of elevation. Notice it's from horizontal to looking up towards a particular object like the sun. That would be the angle of elevation of the sun, from horizontal to looking up. I could, though, say, well, if I took from the sun horizontal and I looked down at that point that I was looking up from, that would be called an angle of depression. Now, we're going to know something about this angle of elevation and angle of depression, aren't we? Those are parallel, so those are equal because alternate interior angles are equal. Two non-adjacent interior angles on opposite sides of the transversal. I always say, well, they make the letter Z. Okay? Then I usually say that, you remember that, Zorro makes that little Z. Zorro makes a Z. Anyway, whatever. And so we have angle of depression, angle of elevation. We need to know that as that would apply to word problems. All right, so we're going to flash that out of the way and talk about this problem. A tree casts a shadow 22 feet when the angle of elevation of the sun's ray is 32. Find the height of the tree. This is obviously something we could really do. We have a right triangle formed by this scenario. We have an acute angle and a side, and we actually want the height of the tree, which we can call t. So we're going to set up a trigonometric ratio to solve. Now, if we're going to do that, what are we going to do first? We're going to find the acute angle first. So the first thing we're going to do is identify an acute angle. And my acute angle was 32 degrees. And then what am I going to do? I'm going to look at the sides given, see how they're related to the angle that I chose, and that's going to tell me which function to use, right? So the 22 is a leg, and it's the one that helps make the 32-degree angle, so it's the leg adjacent. And the tree is a leg, and it is the leg opposite. And so we have leg opposite, leg adjacent, which is tangent, and so that tells me to use the tangent ratio. So we got that. And then to set up our fraction, we do what tangent says. Tangent says you put leg opposite over leg adjacent. And so we have a trigonometric ratio that we can use to solve for the height of the tree width. Never have to climb the tree. Pretty cool. So we're going to undo division by multiplication. And so we have 22 tangent 32. Now, this was measured in 22 what? Feet. 22 feet. So my answer is going to pop out in feet, and it said it wants the answer to the nearest 16th of an inch. Yay, we like that kind of stuff. So we're going to go to our calculator, and we're going to do, I'll clear it out, 22 tangent 30, 23, 32. Thank you. Enter. Now that is, thank you, that is feet, correct? 13 feet, but we don't want 0.74, we want inches to the near 16th of an inch. So what are we going to do? Y'all tell me what to do to make the leftovers become inches. Well, the first thing we need to do is get the leftovers. How do we get the leftovers? We get rid of the we get rid of the 13, right? Whoops. Okay, just a second. Second, enter. Get my answer back. Okay, so we're going to go minus 13. We're going to take that off, and so now we have just the remainder. Now, we want to go from feet to inches. That's larger to smaller. Larger to smaller, you multiply. How many inches are in a foot? 12. So we multiply by the conversion, 12. And we get inches. So now we've got 13 feet, 8 something inches. But we don't want the something inches. So we're going to take off the 8 and change that 0.9 whatever into what's? 16ths. Now, how many 16ths are in a whole inch? 16. So if we want to change it to 16ths, we're going from larger to smaller, so you multiply by 16. And to the near 16th, we've got 13 feet, 8 and 15 sixteenths inches. 13 feet, 8 and 15 sixteenths of an inch. Now that's something you can take your tape measure and measure, but you can't measure 0.934 whatever, okay? So that's pretty important to know how to do in real life. Any questions on that? So there's some trigonometric application that you really would have done in Algebra 1 geometry, maybe, and we're seeing it again in pre-calculus. All right, any questions on that? All right, what we want to do now, then, is go to our pre-calculus worksheet. So I'm going to do that on the blank Adobe scan. We are on the lesson 26 to 27 page. And it's going to start out with a little triangle here. And there's something about this we need to kind of start getting used to. Notice that if it calls this angle A, what does it call the side opposite that? Little a. Now that's going to be important when we get to the law of sines and the law of cosines and a lot of other stuff. Little a is always going to be the side opposite angle A. Okay? And then angle B, opposite it is little b. And we normally would call the right angle C, because if we were thinking Pythagorean theorem, we would kind of want to see a squared plus b squared is c squared, where little c is the side opposite the hypotenuse big C. Okay. Anyway, and so they give us this picture, and then in question number 1 it says if C is equal to 16 and big B, that's the angle, is 67 degrees, and we want to find little a. Okay, so here's what they gave us. They gave us that big B is 67 degrees. They gave us that little c is 16, and they're wanting us to find little a. We got the 3 red things given. Now, it's not 30, 60, 90, or 45, so we're going to have to use a trigonometric function. So what's the first thing we're going to write down? The angle measure. So we would identify the angle first. And that angle was 67 degrees. And then what would you do next? Hang in there, the sleepy people. Try not to say your name on video. Probably somebody watching go, that's me, how did you know? Anyway, so we want to see the sides are related to the angle. So see how the sides given are related to the angle that you chose. Little a is a leg. And it helps make the 67-degree angle, so it's the leg adjacent. Adjacent, that's a D. And the 16 is the hypotenuse because it's opposite the right angle. It's not even a leg at all. So what we have here is leg adjacent hypotenuse. Now, which one of those ratios is that? Cosine. So that tells us to use cosine. So we see how the sides are related to the angle that we chose. That tells us which ratio to use. They see that? And then how do you get your fraction? Do what cosine says. Cosine says you put leg adjacent over hypotenuse. And so we have our ratio set up. Now it's order of operations time. We're going to undo division by multiplication. And so we're going to have that A is equal to 16 cosine 60. Punch it in the calculator and hit enter. When you do, you get, what's that? 6.3 rounded to the nearest tenth as it asks us to do, right? 6.3 rounded to the nearest tenth. Any questions on that? Okay. Everybody good with number one? All right. Number two, I think I'll just erase a lot of this stuff. Well, maybe I just need to start over. I made a mess, so we'll zip that right back in real fast. Zing. I'm not making it pretty, so big C, little c, big A, little a, big B, little b. Number two, on number two, they said big A is 29 degrees. Little a is 4.6. Little c is what we're trying to find. Question mark little c. So we're looking for little c. We've got little a is 14.6. And we've got that, 4.6. Little a is 4.6. And we've got A is 29 degrees. So the first thing we write down is our acute angle. I'll quit all that highlighting stuff. We should have that figured out by now. And now we're going to what? Figure out the sides, see how they're related to the angle that we chose. The 4.6 is a leg. In relationship to the 29, it is the leg opposite. The C, which is what we're looking for, is the hypotenuse. We have leg opposite hypotenuse, which is sine. Sine tells us how to set up the fraction. The fraction is going to be leg opposite, which is over little c. Now we have a different scenario than we've had. So let's give you time to write this and think about it. And then we'll show you how to solve when the variable's on the bottom instead of the top. Okay? Everybody caught up? Now, the easiest way to do this is to just think of this as being over 1. If you do, we now have a proportion. You could just multiply through by the denominator c. Or you can think of that as a proportion and cross multiply. And so we would have sine 29 times c is equal to 4.6. And then to solve for c, we would undo multiplication by division. And those would cancel. And you would have that C is 4.6 divided sine 29. Everybody understand that? And then you just punch it in. I'll punch that one in just so we can see it. But understand what we did mathematically? When the variable's on the bottom, we created a proportion and solved. All right, so we're going to go to our calculator here. 40.6 divided sine 29. 4, I guess I'm going to move it up. 0.6 divide sine, what was it, 49? 49? 29? I usually remember better than this. 29, there we go, enter. 9.5 rounded to the nearest tenth. 9.5 rounded to the nearest tenth. Any questions on that? Applications of trigonometric functions. Okay. Number 3. Everybody good so far? So we've dealt with a variable in the numerator, we've dealt with a variable in the denominator, we've dealt with sine, cosine, and tangent, and we've also dealt with an angle of elevation where we did a real-life application problem. And so now we're on number 3. We'll go back to our little right triangle. We have angle A, side A, angle B, side B, angle C, side C. Number 3 said that little b was 33.2. It said that big B, angle B, was 61 degrees, and it's asking us to find little a. So my unknown is little a, that's what I'm looking for. Side B they gave me to be 33.2, and angle B they gave me to be 61 degrees. So I'm given the blue stuff. Understand that? The first thing I'm going to write down is the acute angle 61 degrees. What am I going to do next? Look at the sides given. Decide the function. A is a leg. It is a leg that helps make the angle, so it is leg adjacent. And the 33.2 is a leg. It is the leg opposite. What we have in relationship to the 61 is leg opposite and leg adjacent, which is what function? Tangent. Understand that? And to get the fraction, we do what that function says. The tangent function says you put leg opposite over adjacent. Now we have a tangent function with a variable in the denominator. How did we take care of it if there was a variable in the denominator? Put it over 1, which creates a proportion, and we cross multiply. A times tangent 61 is tangent 61 times A is equal to 1 times 33.2 is 33.2. We're going to now undo multiplication by division to isolate the A. And so we have A is equal to 33.2 divide tangent 61 degrees, which you would punch in just like you did the other one, and you would get 18.4. Rounded to the nearest tenth. Any questions on number 3? Yes, sir. You could. But you'd have to use that. The question was, as opposed to this, could you think of cotangent of 61 degrees I'll start over. That all kind of got crazy. Could we think of cotangent 61 degrees and use the reciprocal, which would make there not be a variable in the denominator, but you would have to know how to get cotangent 61, which you'd still need to punch tangent 61 reciprocal, right? And that would not be inverse tangent. What you would do is you would do tangent 61, and then you would hit the x to the negative 1 button, right? Not tangent negative 1. Tangent 61 inverse is how you would tell it cotangent, okay? So you would do tangent 61 inverse times 33.2. Okay, I'm going to punch that in just to show you what we're talking about. I think it's just as easy to cross multiply, maybe easier, but anyway, if I wanted to tell it tangent 61, I'd hit tangent 61 degrees. But I don't really want tangent, I want cotangent, and so I'm going to have to hit the x to the negative 1 button right here. That's not inverse tangent, that's the reciprocal of tangent, which is cotangent. Now I have cotangent, and then times, what was that number? 33.2? And I should get the same answer. Okay? Yes. So you could do that. You just have to know how to make it say cotangent, reciprocal of tangent. All right, good stuff. But we needed to know that anyway. Any other questions? Good stuff. Okay, so let's look at the last one. We've got, let's get our triangle again. A, little a, angle C, little c, angle B, little b. We've got that angle A is equal to 16 degrees and 55 minutes. We've got that C is 13.7. And we want to find little a. Thank you. So this is 16 degrees, 55 minutes. C is 13.7, and little a is what we're looking for. So we're going to have 16 degrees, 55 minutes as our angle. The A is the leg opposite. 13.7 is the hypotenuse. Leg opposite hypotenuse is sine. Sine says you put leg opposite on top and hypotenuse on bottom. I didn't give myself much room. I'm going to squeeze the sine in there a little closer. So we're going to multiply by 13.7. So we're going to need to type that in, right? 13.7 sine 16 degrees 55 minutes. Now I need to show you where degrees and minutes are. We don't know where those are yet unless you found it without me showing you. Where's that at and where's that at? There's a couple of places they're at, but the easiest way is catalog. I'll show you how to get there on your calculator. Is everybody ready? Where if the bell rings, just hang with me for about a minute. I won't get too much of your time. So what we wanted to do was, what was in front? Y'all help me there. 13.7? 13.7 sine. Now, it was 16 degrees, 16. Now, here's how you get the degree symbol. We're going to do catalog. See, the catalog is above the 0. See that? So we're going to hit second 0, which is catalog. Now, we're going to go up instead of down, and that's going to get into symbols. That right there is seconds, the 2 dittos. The 1 ditto is minutes, but we're not ready for that yet. We're going to go up until we find a degree symbol. That is not a degree symbol. A degree symbol is going to be round, not square. There it is. back down. Find it, hit enter. It pasted it on there. Now we want 55 minutes, so we do the 55. We have to go back to the catalog, second catalog. Go up instead of down. It'll take you forever to go the other way. Up, up, up. There we have minutes. Enter is going to paste it in. Close our parenthesis. Enter 3.98. Rounded to the nearest tenth would be 4, correct? Any questions on that? All right. Appreciate your attention. Good timing again.